All right, so in this page, we're going to focus on clearing fractions from an equation and then solving equations with fractions. And then we're also going to look at another word problem here and how to write an equation with decimals. So first off, when we're clearing a fraction or we have an equation with fractions, we want to clear them. And what that means is we kind of want to get rid of them because it makes the entire process a little bit easier to deal with. This does not want us to use decimals in our answer, so that kind of gives me a clue that there may be a fraction at the end, although because they're asking us to clear it, they're not actually asking us to solve it. I think they just want us to clear the fractions and then rewrite the equation. So to clear the fraction from an equation, we're going to multiply. Dang, what is my pen's going loopy here? Multiply by the lowest common multiple of the denominator. So what that means is I'm going to look at the denominators. I have 3 and I have 5. And if I go 3 and I go 5, what I want to do is I want to start counting by these numbers. So I have 3, 6, 9, 12, 15, 18, 21. So let's see, for 5, we have 5, 10, 15. Oh, I have a match. So as soon as I have a match, I can stop. I don't need to keep listing numbers. And if you by chance knew that already, perfect. You didn't necessarily have to list the multiples. This is just where I'm getting this number from. So what I want to do is I want to multiply everything by 15. Because what's that's going to do is it's going to eliminate the fractions. So I'll show you how that works. Here, let me grab my eraser really quick. I'll erase this just so that it's not in my way. Alright, so 4 times 15, well, that's a little bit more straightforward. That's just 60. And then I have negative 2/3 times 15. And remember, all numbers have a 1 underneath them, so we're going to multiply by 2. So negative 2 times 15 gives us negative 30 over 3 times 1 is 3, so this gives us negative 10. And there is an x with that, so I should have brought the x with it when I wrote it down. And then I also have 2/5 times 15. So again, there's a 1 there, so I'm going to multiply. 2 times 15 gives me 30. 1 times 5 gives me 5. 30 divided by 5 gives me 6. So now, this is what I want to replace all these numbers with. So instead of 4, I did 4 times 15 and I got 60 here. So it's 60. 2/3 x times 15, well, that got me negative 10x. And then 2/5 times 15 got me 6. So now I have a much easier problem to deal with because I eliminated those fractions. We can definitely solve it with the fractions, but eliminating them makes it much easier to deal with. Okay? So they didn't actually ask us to go solve. We are going to solve this next one with some fractions. So first, let's go ahead and eliminate those fractions. So again, I'm going to erase some of this work here just so I have a little bit more room. Okay. Oh, pen back on. All right. So 7, 2, and 3. So if I list the factors, 7, 2, and 3. So if you list the factors of 7 first, since it's the bigger one, that actually kind of helps you so you're not doing a whole lot more for these ones. So I have 7, 14. 14 would work with 2, but not with 3. 21, that would work with 3, but not with 2. 28, that would work with 2, but not with 3. Let's see, then we would have 35. That doesn't work with either one of those. And then we're going to have 42. So let's see, this would work with both 2 and 3. So, and the reason I know that going down, I know it's divided by 2 because it's even. And it can divide by 3 because if I do 4 plus 2, I get 6. It's kind of a little threes trick. 6 can divide by 3, so 42 can divide by 3. So it's just one of those little tricks. So I know it's going to be 42. That's actually the number I'm going to focus on. So I didn't actually go through and list all of the factors because that's going to take me a very long time to count by 2's to get to 42 and then 3's to get to 42. So instead I focused on that larger number and I just kept going until I found something that can divide by both 2 and 3. If you weren't sure, you can do each one you can divide. Does this divide by 2? Does this divide by 3? Nope. Does this divide by 2? Nope. Does this divide by 2? Yes. Does it divide by 3? No. So you can keep going. If you need to use a calculator, do some long division there, for each one, that's perfectly fine. So we're going to we're going to multiply by 42 all the way around. So 1/7 times 42, remember there's a 1 underneath, so 1 times 42 is 42. 1 times 7 is 7. 42 divided by 7, well, we made a list. That's 1, 2, 3, 4, 5, 6. So that equals 6, so we're going to have 6 here. And then we have 1/2. I end up with a whole lot of fractions all over the place here. Negative 1/2 x times 42. I'm going to bring that up a little bit. Over 1. So I have negative 1 times 42 gives me negative 42 over 2 times 1 gives me 2, and the x is just kind of off to the side here. So I'm going to divide by 2. So I get negative 21. So negative 21x. And then I'm going to do this last fraction here. So I get negative 2/3 times 42 over 1. So 42 times 2, I get 84 negative, because it was a negative. And 3 times 1, I get 3. So now I'm going to divide. So let's see, if I go over here and I go 84 divided by 3, I can ignore the negative for a moment. I know it's going to be negative, so I don't actually need to put it here, especially if that's kind of confusing. If you don't like seeing that there, that's fine. So it goes in here twice. We bring this down, 24, and that goes in 8 times. So we get 28. And negative 28 equals negative 28. All right, so now I can go through and solve this just like we have for all those other two-step equations we have on the last video. I think it's the last 2 videos. So I say, what's being added or subtracted on the same side as the variable? So be careful, this negative 21 is not being subtracted. It's being multiplied by x because it's right next to it. What's being added or subtracted is the 6 because it's kind of by itself, it's not being multiplied by anything. So this is what we're looking for. So I'm going to subtract 6 from both sides, and I get 0. 6 minus 6 cancels. Negative 21x equals, and in this case I have negative 28 and negative 6, so I can just add them together. I get 14 and I get 3. Let's see, I get 34 negative. Because they were both negative, I'm just adding them together. I start out with negative 28, I want 6 more negative. And now I'm multiplying by negative 21, so I'm going to do the opposite. I'm going to divide by negative 21 on both sides. Negative 21 divided by negative 21 cancels out. And I have x equals negative divided by negative is going to make a positive. I have 34 over 21 is going to be my answer. So it's this kind of little funky looking fraction, but we get a fraction on this one. So we're simplifying as much as possible, and that's as far as I can go because these can't divide by the same things. 34 can divide by 2 and 17. 21 can divide by 3 and 7, so nothing can cancel there. All right, our very last question here. Maya got a prepaid debit card with $25 on it. For her first purchase with the card, she bought some bulk ribbon at a craft store. The price of the ribbon was 8 cents per yard. If after the purchase there was $21.48 left on the card, how many yards of ribbon did Maya buy? All right, so we're just going to kind of look at the situation. Let's think about it. So first of all, she had a card with some money on it. So how much did she start with? Well, she started with $25. That's that very first part. Maya got a prepaid debit card with $25 on it. So we know how much she started with. For her first purchase on the card, she bought some bulk ribbon at the craft store. So what did she buy? Ribbon. And we can say bulk ribbon or just ribbon. Totally up to you. I'm just going to be a little lazy. I'll underline the ribbon. What do we know about the item? So what do we know about the ribbon based on this story? So we know she bought the bulk ribbon at the craft store, and the price of the ribbon was 8 cents per yard. So we know the cost. It's 8 cents per yard. And then what was the credit on the card after her purchase? So basically, what's her total? So after the purchase, there was $21.48 left. So we want to set up an equation and then solve this equation so that we can figure out how many yards of ribbon did she buy. So we know she started with $25 and she spent something. So we're taking that spend away. And she spent $8 per yard. Or sorry, $8, 8 cents per yard. So we want to make sure that this is going to be multiplication. It's 8 cents per yard, or you could do R for ribbon, however you would like to do that. They're not specifying which variables you have to use. So we're going to subtract the 8 cents per yard. We don't know how many yards she bought yet. We're going to figure that out. And then that's going to equal what's left over. Okay, so now we can go through and start solving this. So I want to go what's being added or subtracted on the same side as the variable. Again, be careful, it's not the negative 0.08. That's being multiplied by y. What's being added is this positive 24. So I'm going to I'm going to subtract 25 from both sides. Like this. Whoop. So 25 minus 25 cancels out, and I end up with negative 0.08y equals, and in this case, if you were going to subtract straight down, you want to be careful about this. I'd actually want to flip it over and go like this, because you always want the larger number on the top. You don't want to subtract it straight down, because you will not get the correct answer, because you won't be borrowing correctly. So just make sure you rewrite it if you're going to do it this way. So you get negative 352. When we subtract straight down, because we're going to have to borrow, and that turns into 9, and that turns into 10. So we get 2, we get 5, we get 3, and the 2's cancel out. And it's negative because the 25 is bigger and it's the negative. So now I'm going to rewrite this so that we can actually see it over here. All right, so our last step is to undo the multiplication. So I'm going to divide by the negative 0.08. And I do believe Alex provides you a calculator on this one, but we can always do this without a calculator. So anything divided by itself cancels out, so the y is left behind, equals a negative divided by negative is going to be a positive. And now we want to do our division, and what I can show you really quick, because it does make it a little bit easier. This is not horrible to do long division on. So we have 3, 5, 2 divided by 0.08. But we wouldn't actually write it this way. What I would do is I would move this decimal so that it's a whole number, and I moved it twice, so I'm going to move this twice. So I'd actually do 352 divided by 8. So I don't even have to deal with all these decimals here when I'm dividing. Okay, so now when I'm looking at this, it can go into 32, let's see, 4 times, because the closest we can get is 32, and then we'd have 32 left over, so it's another 4. So it looks like she bought 44 yards of ribbon. So that was clearing fractions and solving equations with fractions and decimals. All right, go ahead and give a try on Alex.